Hello, and welcome to 5 Minute Math. My name is Aaron Daffern, and today we're looking at the entire third grade 2024 Mathematics STAAR test. You can access the item analysis report that I used for this video using the QR code or the tiny URL you see on the screen, or you can go ahead and skip ahead to any item you want to using the timestamps on the screen or the bookmarks at the bottom of the video. So for number one, it asked us to think about the school with 375 hot dogs to sell, and then at the end of the carnival, 83 hot dogs were not sold. So what we needed students to do here, it probably would have been good to draw some type of strip diagram, right? So we could have first found our total. That's our total, 375. And then there were two quantities. There was the quantity sold, and there was the quantity not sold. And so we've got sold as our unknown. We've got 83 not sold. And so the question is, how many hot dogs were sold? So if you were to set it up in something like this, then you would see, okay, this is a part whole. We can subtract 375 and 83. And that's going to get us the part that was sold. So 5 minus 3 is 2. Let's regroup there. And that's going to be 292. So our correct answer here is A. Now let's see how we did across the state of Texas. We had 69% of our students actually choose A. So this made this the fourth easiest problem on the entire test. This was fairly easy. It was a nice softball for students to be able to start the test. We had some distractors here. We had 13% of our students choose B, 312. That's where you subtract, this is an interesting one. You subtract 83 minus 375. Obviously, we're doing this wrong here, but 3 minus 5 is 2. There's your 1. There's your 3. So if you just set it up completely wrong and ignore the problem you have here, you could get that 312. Right, 458. Option C, 10% of our students chose this. And that's just simple addition. You do 375 and 83, and instead of subtracting, you think you need to add, and that's your 458. And then we only had 7% of our students get the 282. And when we're doing that 282, we're doing some kind of strange subtraction to kind of get to this 282. We're setting it up backwards. So this was a fairly simple problem to start out with. 69% of our students, which is really good, chose the correct answer of A. So for number two, we have to figure out this series of clues and how it's going to help our students identify a number, right? So we have a number that needs to be greater than, let's see what they give us here. So greater than 89,000, so I'm going to put that right here, 89,236, less than 91,103. Okay, so somewhere in between there, and has a digit greater than 7 in the thousands. Well, first I need to see which of these land in between, and then let's find a digit greater than 7 in the thousands place. So this 88,000, you see 88,000 is going to be less, right? 88,598 is going to be less simply because 88,000 is less than 89,000. So that's not it. 91,000, 91,000. So those are the same. So I need to compare, right? The 57 and the 103. The 57 is less than 103. So that could possibly be. So that's a possibility. 057. 89,099. Well, 89 works possibly, but that 99 is still less than that 236. So I'm going to put that right here. So I can eliminate A and C simply because they don't even match They don't even match the clues. Then I've got my 89, 572. 89 matches the 89 here, but the 572 is larger than the 236. Okay, so I've got another possibility. I've got two possible answers. Now, and these are our numbers we're trying to fit in between here. I need to look at this last clue. Has a digit greater than 7 in the thousands place. Well, what's in my thousands place here? If I look at my place value, my thousands place is 9. And in this case, my thousands place is 1. And so obviously this 9 is greater than 7. So this is going to be my answer right here, the 89,572. So this actually only got, so let's make this our correct answer here. This was a little bit more difficult. 59% of our students in the state of Texas got this correct. And this was the 12th easiest. Now, this is a 30-item test, so even though it landed a little bit more on the easy side, it is kind of in the middle of the test, right out of a 30-item test. It tied for 12th. So let's see what some of the incorrect answer distractors were. So we had a pretty even amount. 13% of our students choose A. And so what we did here was we just kind of looked at clue 2 and 3. And if you get clue 2 and 3 and ignore clue 1, A makes sense, but it doesn't fit clue 1. B is 19%. So out of our incorrect answer choices, that was the most common. Now, this obviously just disregards the third clue, and it really kind of misinterprets this second clue. It somehow thinks, right, that just because it fits here, that we're good, but it fits the first and second, but it doesn't really look at that third clue. So it doesn't help. But they did 2/3 of the work and just kind of fell apart on that third clue. And then C just doesn't really kind of make any sense because it doesn't fit uh, this very first clue. I mean, obviously it fits these last two clues, but it just doesn't fit that first clue, and that hopefully would be the first one that our students look at. Least amount of students chose that, 9%. So our answer here was D. So for number 3, students are asked to interpret this data here. Right? So Ben is rolling a number cube 10 times and records these results here. And then we need to create a dot plot. Now we already have a dot plot there, but it's incorrect. So it is incorrect because, so basically let's make a frequency table here. And I've got my numbers 1, 2, 3, 4, 5, and 6. And let's just cross out. I've got a 1 here. It's going to I've got no 2s. 3, 3. So I've got 2 3s. 4, 4, just 2 4s. I've got 1, 2, 3 5s, and then 2 6s. All right, so we should be able to take this data set, transfer it into a frequency table, and then we need to see how does it match to our dot plot, okay? So I've got a dot above the 1 dot here that's good. I've got no dots on the 2, no dots on the 2, that's good. I've got 2 dots above the 3. We're good. Ah, look at that right there. That's my issue. I should have 2 dots above the 4, and I've only got 1. Let's double check the other 2. I've got 3 dots above the 5. We're good. 2 dots above the 6. Okay, so my problem is the 4. It only has 1 dot. I should have 2 dots. And if we can put a second dot right here, it would actually be a correct dot plot. So let's look at our answer choices here. Ben's dot plot is incorrect because there should be how many dots above the number, and then now here's the thing. It's not saying how many dots I need to add, and this is probably where students got confused. How many dots should there be? There should be, remember what we said, 2 dots. Even though I only need to add 1 dot, there needs to be 2 dots above the number 4. So this is a 2-point problem. That's how we get both points. Now, across the state of Texas, what we have here is this is a full credit here is going to be 52%. So 52% of our students got that 2 points. 22% of our students got 1 point. And then we've got 0%, 0 points. We had 26%. Now, one way to calculate quote unquote percent correct, because you get half credit for this. So what we do is we take our full 52. We're going to take half of the 1 point, so that's plus 11. So really we look at 63% as our quote unquote percent correct, because you can get partial credit on this, and that's fifth easiest. So most of our students were able to be successful. It was tied for the fifth easiest across the test. At 63% is pretty good. If I were to guess, we don't have any data as to which incorrect answers they chose from the drop-down menu, so we don't get it from that. My guess is that this is going to be the biggest problem. I think most kids were able to identify the number 4 was the issue. But if you're not reading it correctly, I can see how you think this answer needs to be 1 dot because you added 1 dot. But we need to read the entire sentence. There should be 1 dot above the number 4. Doesn't make sense. There is 1 dot. There should be 2 dots, and that's just a matter of reading carefully. All right, for number 4, we are looking at the relationship between 2 digits in this number. This is a very difficult standard. It's a supporting standard, and it's hard for students to understand unless they have a deep conceptual understanding of this. So I'm going to draw a place value chart here. And I'm going to make like a big line right there to separate the 2 periods. Okay, and so that's ones, tens, hundreds. And then on my thousands, right, it's 1,000, 10,000, 100,000. I'll just go ahead and name the place. So let's build our number. 583,436. Now what's going to be helpful here is what I want to do is I want to write the value of each digit underneath, right? So 6 in the ones place is worth 6. 3 in the tens place is worth 30. This can end up being like an expanded form if we really wanted to. 4 in the hundreds place, 400. 3 in the 1,000s is 3,000. 8 in the 10,000s is 80,000. And then a 5 in the 100,000s is 500,000. Now, let's look at our answer choices here. The 10,000s place is 2 times greater than the tens place. So once I have these values, I can actually make this a statement. A says the 2,000s place, so the thousands place, excuse me, is 3,000. So I can say 3,000 is equal sign 2 times greater than the tens place. So the tens place is 30 times 2. No, 30 times 2 is 60. So this is incorrect. It's 2 places to the left, but each place is worth 10 times. And 10 and 10 is going to make 100. So if students got this one correct, right, they noticed it was 2 places to the left, but they didn't necessarily know that each place is worth 10 times. And I'll tell you, let's go ahead and add these as we're going. We had 22% of our students, almost a quarter of our students, choose this incorrect answer. B, the thousands place, once again, 3,000. So we're just dealing with the thousands place here. Look at all of our answer selections. Thousands place is equals 10 times greater than the tens place. Tens place is 30 times 10. Well, we're getting closer. 30 times 10 would get us one more, but that only gets us one place over. This is going to be worth 300, not 3,000. Across the state of Texas, we had same amount. 22% of our students choose this. Let's look at C. The thousands place, 3,000, equals 100 times greater than the tens place. Tens place is still 30. 100 times greater. Okay, so that could possibly be, because look, I'm taking 1, 2 jumps. Every jump to the left is worth 10. So 10 times 10 is 100. And if I take my 30, and if I know what happens when I multiply by 100, right, what you end up doing is you just take those two zeros, you bring them down, add them to the end, you get your 3,000. So this is the correct answer. And so I'm going to go ahead and mark that as our correct answer. But we only had 35% of the students across the state of Texas choose this correct. That is a very, very low percent. Let's finish this out and look at D. The thousands place, 3,000, is 300 times greater than the tens place. Okay, so 300. So the 100 makes sense, but not 300. So it's just different variations of trying to figure out how to get from 30 to 3,000. And for this one, 20%. And so whenever you see something like this, this lets you know that we have a whole lot of guessing. When your answer choices are, for the most part, evenly distributed, obviously more students chose the correct answer than the incorrect answers. But when you're getting close to 20, 25%, that's just statistically what happens when students guess. And I can guarantee you there's a lot of students that chose this correct answer and didn't know what it meant. It was just a guess. And this was the seventh hardest item on the entire test. So this is definitely a standard that we need to provide a little more opportunities for our students to access 3.2b. All right, so for number 5, we are looking at scarcity of resources here. This is personal financial literacy. This is 3.9b. And so let's see what we have working here. 3.9b. And really, it's just identifying. There's no mathematical calculation involved here. What we're doing is we're trying to just identify what happens when you plant more orange trees, and that means you have more of an orange crop. Okay, so as the supply goes up, what happens to the prices? So that's the question, right? So the price is either going to increase or decrease. Those are our two choices. And even if you can figure out whether it's going to increase or decrease, well, then you still have to figure out why. So first off, we can eliminate two answers here just by looking at this. If you have an increase, so that's our key, increase in the orange crop. So the orange crop is your supply. So if you have an increased or a greater orange crop, does that mean there are more oranges or fewer oranges? Hopefully, we would get our students to think, okay, an increase in the orange crop means more oranges. So I'm going to eliminate C and D. Now, if my supply or my number of oranges increases, what happens to the price? Now, this is something that students might not know intuitively, so they would have needed a lesson or two to kind of figure out how this works. But we do know that as the supply goes up, the prices will drop because there's more and more available. The items that are available are less and less precious, so they're worth less. So we are going to know that with the prices are going to likely decrease because there are more oranges for sale. As the supply goes up, the prices go down. Now, this was fairly difficult. Let's see how we did across the state of Texas here, right? So we had 38% choose A, and we had 44% choose B. Now, they were stuck between those two, and we had almost as many students choose A as B. But take a look at the breakdown here. So obviously, I mean, we had over 80% of our students choose either A or B. And that means that 82% of the students were at least able to access this clue right here, right? The fewer oranges doesn't make sense with an increase. So that's kudos to our students for at least figuring that out. What they need practice with is what happens when the supply goes up. Supply goes up, prices go down. There's various ways to illustrate that. This is kind of a difficult financial literacy standard for students to access, and so they would probably need quite a bit of practice for this to stick for them. All right, so let's look at our next item, number 6. So Zachary's got these figures here. We are trying to figure out some perimeter, and this is going to be standard 3.7b. And we just need to find all the perimeters that have 36 feet. So really, it's just a lot of calculation. That's really what that is. The answer selections are a little bit strange, but let's just calculate all of these, right? So let's calculate P. There's a lot of different ways to do this. I'm just going to make those two to be 10. So 13, 10, and 13, if we add it up like that, right, that's going to be 36. Okay, so this works. So P works. This, I need to go 1, 2, 3, 4, 5, 6. This is 6 groups of 6. Also 36. P and Q both work. Let's look at R. I want to make each of those to be 18. There's two sets of 18, 36. So far, P, Q, and R all work. I've got three 12s. Okay, so three groups of 12. Guess what that is? 36. Now, this is the one that doesn't work. This is four sets of 6. This is 24. So, what we need here is we need P, Q, R, and S. So P, Q, R, and S is going to be this very first one. Let's see how we did across the state of Texas. So we actually did all right. I mean, we had 71% of our students able to get this. So hopefully we should feel very confident about this. You have a lot of calculation to do, but quite honestly, this is one of the more easier type of perimeter problems where they're literally just adding all the way around a figure. It's when they have the perimeter of a rectangle and they only are given like the length of the width. That's that's where it gets difficult, right? And we see here that the second most chosen answer is C. It's 14%, and P, R, and S so they just missed the Q. So for some reason they didn't necessarily see that as 36. But for the most part, we should feel pretty satisfied with this. This is the third easiest item on the entire test. Anything over 71%, you check it and move on. You're feeling pretty good. So let's look at our next problem. For number 7, we are representing addition and subtraction. So this is standard 3.5a. And we've got this story here about Jada traveling to visit our aunt. It lives 789 miles away. So she needs to travel 321 more miles. So how much has she already traveled? Well, what we need to see here is that when you give us this, she's traveling to her aunt who lives 789 miles away, right? That's a total 789. So she needs to travel this many more. How much has she already traveled? So these are the two different parts for our strip diagram. So we don't know how much she's already traveled, but we do know that it's 321 miles more. All right, so we need to find two correct answers. This is a multiple select question. And so what do we see here? Well, we need to see which of these answers have 789 as the total. So this has it as the total. This has it as the total. This one does not. This one does not. And this one has it. So we can't choose three answers. So one of these three is going to be incorrect. And you'll notice here that if we take a look at this first one, doesn't really make much sense, right? 321 subtracting to something makes it bigger. Unless you're subtracting a negative, that's not going to work. So this one doesn't make any sense. And really, it's this one and this one. That second and that fifth option, those are the ones that make sense, right? This is what I drew, and this is how we would draw it as an addition problem, right? 321 plus the unknown number will get us to our total of 789. So our two answers are going to be right there. Now this is a 2-point problem, so we don't know how many students got each of these answer choices, but we can tell you how many students got 2 points and 1 point and 0 points. All right, so 2 points is full credit, and we had 40% of our students get that. 1 point is half credit. They got one of the two, and that is going to be 39%. And then 0, right, is that 21%. So if you put these together, right, you're almost at about 60%, right? We take the full 40% and half of that, which is 19.5, which rounds up to 20, gets you about 60% correct on this item, which makes it the 10th easiest. It's a tie for the 10th easiest, so it's on the easier side, but it's kind of in the middle. If I were to guess, we don't know which of these answer selections they chose. If students are drawing this picture, my guess is this is the one that they probably are able to do. And I'm thinking this is the one, especially these two. These two probably confused them. They knew that 789 was the total, right? So what we really need to do is spend time working with our kids. Once we get a good representation with the strip diagram, making sure we can identify, are we adding, are we subtracting, what do we need to do to get up to that total? So for number 8, we are looking at rounding. This is 3.2c, and we have to put a number on the number line here, and it is supposed to be more than halfway between 200 and 300. All right, well, I've already got a number line for me here. There's 200 and 300. I need to find something that is more than halfway between 200 and 300. So let's plot all of these points. So my midpoint here between 200 and 300 is going to be, let's see, that's 250. All right, so 225 is, and I'll put these in a different color. 225 is halfway in between 200 and 250. 208 is a lot closer to 200. I've got 264, which is past 250. 264. Then I've got 250 itself. All right, so there's 250. Now, one of these is correct. Look at our clue here. More than halfway. So these two are less than halfway. 250 is halfway. But I don't want one that's halfway. I want one that's more than halfway. So the only one that's more than halfway is going to be this 264. Now, if you were thinking 250 originally, well, then you are going to be like most students in the state of Texas. So only 7% of our students chose A. Only 6% of our students chose B. So for the most part, those were just guesses. Students didn't know what to do. Check out how many students chose D. 63% of our students chose D, and only 23% of our students chose the correct answer of C. This is the second hardest on the entire test. And this really isn't a rounding question. This is a reading question. We need to spend time with our students making sure that they read every single word in these clues. If we're just grabbing numbers and we're not really analyzing this problem itself, we're going to miss a key clue like more than halfway. It would have been great if they would have bolded and and italicized that like they'll do sometimes, right? If we would have had like capital M, like we'll do with the word not, but that would have been a little bit more obvious. So this is a reading question more than a math question, and we need to help our students make those connections the next time they face something like this. All right, so we're moving on to number 9, and that is representing multiplication, 3.4e. And so what do we have to do here when we're representing this multiplication? Well, we are solving a problem by skip counting. Here's the work. And we've counted 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. That's our answer. So we're skip counting by fours. Okay, so I'm just going to say skip counting by fours. And which equation, see here, they don't bold it, but at least they put it in all caps. Cannot be used. So we need to find the one that does not work. Well, 10 times 10 is 100, and then times another 10 is 1,000, times another 10 is 10,000. So 10,000 does not equal 40. This would work if this were 10 plus 10 plus 10 plus 10. What this is this is 4 times 10, while this is 10 times 4. But they gave you the multiplication rather than the addition, right? So this is going to work. This is going to work. This is literally what they did. This is the 4, the 8, 12, 16, 20, 24, 28, 32, 36, 40. So all three of those work. I'm looking for the one that does not work. So that answer is A. That was the very first one. And we had 59% of our students choose this one incorrectly. It is a little bit tricky because you have to find the one that does not work, but our students have seen that enough to where, for the most part, they're looking out for that. Only 9% chose B, 8%. These are pretty obvious. Now, what's interesting is we had 24% of our students choose D because they probably didn't take the time to add up everything, count how many tens they are, or they might not see that skip counting is the same as repeated addition, which is the same as multiplication, which is what we're doing. And so what we need to do on this particular standard is to help our students see multiplication in a variety of forms. We could have done an array. We could have done an area model. We could have done equal skips on a number line. There are so many ways to represent multiplication. They need to see all of them. And overall, this is our 12th easiest. It's a tie for the 12th easiest. So it's kind of right in the middle of difficulty on this test. For number 10, we are looking at unit fractions. This is 3.3c, and Byron is drawing a fraction model below. He claims, because that doesn't look like a fraction model that I'm used to, he shaded 1/7 of the whole model, right? Well, let's count the pieces. 1, 2, 3, 4, 5, 6, 7. Okay, at least there are 7 pieces and one of them is shaded. But we need to, even if we don't understand what this word means, hopefully our students are used to this idea. That word claim might be a little bit confusing for some students, but we need to be able to understand, is this claim? And then let's look at our options. Correct or incorrect? And this is a 2 different drop downs, but this is only 1 point. This is different from most of your inline choices that have 2 drop downs or more, which gives you 2 possible points. This is a 1-point problem. His claim is correct or incorrect because 1/7 of the model should be represented by 1, shaded part out of 7 parts of any size. Okay, so let's take a look. Is this 1/7? Hopefully our students will see this is not 1/7. So we need to be able to understand that term incorrect means it's not true. But this is where it gets tricky. Take a look at what it says. It doesn't ask us why it's incorrect. It asks us because 1/7 of the model should be. So what would make it true? So unless we're reading this, I can see a student possibly selecting represented by one shaded part out of parts of any size because that they're trying to describe what Byron did. But this is not asking for that. This is asking for what it should be. So that's the difficult part here. This is how we get that 1 point. We don't know if students got it wrong, which of the two options they got wrong. They don't give us that information. And so this is simply 56% correct. This is the 15th hardest. So it's right in the middle of a 30-item test, 56%. You had to get both items correct in order to score a point on this particular problem. For number 11, we are looking at arrays, and this is 3.4D. Now, what makes this kind of confusing here is we've got this board here, 8 rows on each row of a game board here. One row is shown. Okay, so this is the row that is shown. How many squares are on the 8 rows? So really what we need to imagine is that we're going to extend this down, right? And there's going to be a total of 8 rows. So I've got 2, 3, 4, 5, 6. And if I do this, that gets me 7, 8. I've got 8, 8, 8, 8, 8, 8, 8, 8. If I wanted to draw, I can, but I just know there's 8 on each row. So hopefully what we're thinking here, all right, so there's 8 sets of 8. That's just 64, okay? So that is going to be our answer here, D. Let's see how we did. For A, we only had 99%, right? So you had to really think hard to get A because that's the 7 more rows. That's 7 times 8, and you didn't count the visible row. It doesn't make sense. Now, I can understand this one. 23% of our kids chose 8. Why would they choose 8? Well, first off, there's 8 squares being shown. I've got an 8 right here. I've got an 8 right here. If I don't know what I'm doing, at least I can bubble in the number that I see, right? So they didn't really understand. This 16 doesn't really make much sense. You just double the visible row, or maybe you add 8 plus 8. Not many students chose it, and we actually had 60% of our students. So that's pretty decent. This is our 10th easiest, tie for the 10th easiest. But anytime we get to 60% or more, even though they would be low on a grade in regards to star scores, it's not doing too bad. We're kind of comfortable with that. So next, for number 12, we are dealing with quadrilaterals. So this is 3.6b. It's all about our vocabulary here. Scroll this down here. We've got 7 pieces on this tangram puzzle. First, we need to describe the 2 quadrilaterals. I need to know what a quadrilateral is, because if I don't know what a quadrilateral is, I've got no clue. There's nothing on the reference materials to help me. So quad means 4, right? So we should be able to at least say this is a triangle. I know that's not a quadrilateral. This is a triangle. I know that's not a quadrilateral. This is a triangle. I know that's not a quadrilateral. This is a triangle, different shapes and sizes, not a quadrilateral. This is the smallest one, but this is also a triangle. So guess what? If I don't know what a quadrilateral is, if I start naming shapes, there are only 2 shapes here that are not triangles. And it asks for 2. So guess what? Those are my quadrilaterals. Now, if I know that, what can I eliminate. Well, this one says parallelogram and triangle. Okay, don't know what a parallelogram is, let's assume, but I know it's not a triangle, so I can eliminate that. And this is one in which most students should be able to recognize. We work on that in pre-K. That's a square. So I need this one, and I need this one. Look at D, also says triangle. Okay, so just by process of elimination, I'm getting down to what is this one right here? Is that a parallelogram, or is that a trapezoid? If we don't know, some students remember a trapezoid. They're pretty good with that. That is a trapezoid. The traditional one, you can also have a right trapezoid, so let's not get too locked in just that first option. And if they think it's not a trapezoid, then it is a parallelogram, right? A parallelogram is simply a quadrilateral with two sets of parallel sides. That is a parallelogram. So our answer here is A. Let's see how we did here. We had only 48% get the correct answer. Let's see how we did on the other answers. We had 15% with the parallelogram and triangle. We had 22%. Square and trapezoid, we had 15%. Okay, so we had a lot of guessing, and it looks like our second most chosen answer does have at least the square. They at least identified the square, and they were kind of choosing between the two. This is all about vocabulary. Kids need tons of exposure and experience describing these shapes, classifying these shapes into different types of quadrilaterals, like that's a whole thing, and also just naming them again and again and again. For number 13, we are looking at real-world number pairs. This is 3.5e, and what we need to do here is we need to find the relationship that exists here between the burritos and the pounds of meat. So 6 burritos makes 1 pound of meat. So let's just put that into our own table first. And since they give it to us like this, we'll just write it in that order. 1 pound of meat, right? So easiest thing to do would be to double that, right? So 12 burritos and then 2 pounds of meat. Let's see, even within that first set of rows, if we can eliminate any answers here, right? I mean, look at this. 7 and 1, 2 and 8. I'm not sure where they're getting that, but they literally told us 6 burritos for every pound of meat, so it's not that one, right? So B is a maybe, right? Because we've got the first 2 rows like we've got it here. Now, look at your labels. 1 burrito for 6 pounds of meat. They've swapped them. That's a lot of meat in 1 burrito. That's a very large burrito. They swapped that. And then take a look at this. 6 burritos, so this looks good. But then they did 12 burritos for 7 pounds of meat. That's not keeping the proportion the same, so this doesn't work. So we don't even have to continue this into the 60 and 10, the 84 and 14, because really what we're doing here is we're dividing by 6. Just by looking at the first 2 rows, we can see that our answer here is going to be B. Now let's see how we did across the state of Texas. And if we're looking at our answer selections, right, A, 13% of our students chose this one. The correct answer, once again, was B, and we had 48, so not even half of our students were able to get this one correct. And then we had 14% of our students get this one correct over here, and then 24. So the most chosen incorrect answer was D, and you'll see it is because we at least have the same first row. So what we need to help students do is make their own table. And I didn't even need to complete my table. I could have, right? I could have added 18 burritos and then 3 pounds of meat, but that wouldn't have helped us because none of the tables had that combination, right? This had 18 and 13. That would have helped me figure out that D is wrong. But students can make their own tables first before simply just trying to read and match what they think is happening with one of the tables in the answer choices. So this was the tied for the 12th hardest item, so kind of right in near the middle, slightly on the harder side. So for number 14, what we're doing here is we are looking at solving data problems. This is 3.8b, and we've got this dot plot here. And Joseph ran a total of 25 miles during the 6 days. So he ran on 5 days, and we've got this 1, 2, 3, 4, 5. Then he ran one more day, but the dot is missing. So we're missing that sixth dot. And so this 25 miles is the total for 6 days. So let's just say he ran these in order. Okay, so I'm going to put a day, and I'm going to say miles. Okay, doesn't matter if they're in order or not, but this is going to help us keep track of things. So on day one, let's say he ran 0 miles. Okay, because that represents a day. On day 2 and 3, he's going to run 2 miles each day. And then I've got on day 4, he's going to run 5 miles, right? Wow, big run there. Day 5, he ran 8 miles, and he ran a total of 6 days. We have a missing number, and then our total needs to be 25. So hopefully you see what we're doing here. Okay, we just need to add all of these up and see what we're missing. So if I look for a 10, 8 and 2 is 10, and then a 2 and 5 is a 7, so that's going to end up being 17. So this right here is 17. I need a missing number on that 6th day to get up to 25, right? And then hopefully we see, all right, so we need to run 8 more miles. So if we put another 8 on the dot plot, we would get a total up to that 25. Now let's see how we did across the state. We had 28% of our students choose A. The correct answer here was B. Only had 32% of our students choose that. 22% and then 18%. So this is awfully close to just random guessing. And so this is one that's very much a reading and a context problem. There's not much difficult here with adding up. You don't even have to add up to 0. Add up to 4 numbers and subtract that from 25 is not that difficult. Understanding that you have to even do that, that's the difficulty, right? So students, if you're stuck, right, you see the number 6, there's the number 6. So that's probably why a lot of students chose that A. Now, here's the sad part. The people that chose C, they knew what to do. They added up the values here, and they got up to 17. They just didn't take that final step of understanding that they ran a total of 25 miles. And then this 10, you just have to do some random stuff to do that. Subtract each of these numbers once from 25, and you can get there. So it's kind of random. So this is a very difficult one. This is the 6th hardest item on the test. Very much more about reading and understanding the problem situation than actual mathematical computation. All right, so for number 15, let's see, we got to get that in there. We are looking at representing multiplication and division. This is 3.5b. And as you can see here, this is a drag and drop. So we have to just create an equation here. We've got some missing operations, and each answer can be used more than once. Right, so this is standard 3.5b. This is worth 2 points, one for each of these blanks. So a sports complex has 4 basketball courts. You know what? Let's read each sentence and then draw a picture. So I'm going to draw 4 basketball courts. I'm just going to draw rectangles. But here we go. It says there are 4 basketball courts. I can draw 4 basketball courts. There are 2 bags of basketballs for each court. So I'm just going to draw circles. Those are going to represent my 2 bags. This strategy where you read something and then you immediately draw a picture for each sentence is something that each kid can do. Then each bag contains 7 basketballs. Since that's the end of the problem situation, I don't need to draw 7 little circles in there. I'm just going to put the digit 7. All right. So complete the equation to figure out the total number of basketballs. Well, I can figure out how many basketballs I've got, right? I've got 14 on each court. Then I can add that up if I want to, and then I can just use that to check my work, right? So 14 14 is 28. 14 14 is 28. So that should equal 56. So whatever I come down here and do should equal 56. Okay, so what did I do with the 4 and the 2? 4 is the basketball courts. And then there were 2 bags on each court. So did I add 4 plus 2 to get 6? No. Think about how many bags I have. 1, 2, 3, 4, 5, 6, 7, 8. There were 4 sets of 2, 4 groups of 2, which means I multiplied those. Okay, so that gave me 8 bags. Now, each bag contains 7 basketballs. Did I add the 7, divide by the 7, multiply by the 7, or subtract the 7? Well, I had 8, because this is my 8 right here, right? I had 8 sets of 7, because there's 7, 7, 7, 7, 7, 7, 7, 7. So that, once again, is the same operation. I multiplied. So I ended up multiplying twice because I had 8 sets of 7 or 8 groups of 7. Now, I think all of that equals 56. Take a look at what happens here. To verify my work, 4 times 2 equals this 8. 8 times 7, basic fact, that's 56. All right, so we know that works. So that is our answer. Now, this is a 2-point problem. So let's see how many students got 2 points. Only 29% of our students got both multiplication points. If you got 1 point, that means you got multiplication in one of those slots, but some other operation in the other. We don't know which one the other one is or where it lands. That was 49%. Okay, so that's not really that wonderful, right? So if we're looking at that, that's about 54%. If we take that, the full one of this, half of this, right? That's about 54% is our correct. And 0 points, 22% just got nothing, which means they most likely were just guessing, pulling random things down. This is our 14th hardest, so it's right in the middle, just barely on the harder side, then the easier side. Draw a picture. When they're giving you something as simple as this, 4 basketball courts, draw 4 rectangles. Put 2 bags of basketballs on each court. Draw 2 circles on each court. So when students are drawing pictures to represent the problem situation, they have a much better chance of solving the problem. All right, so for number 16, we are looking at 3.6e. This is unit fractions and shapes. 3.6e. So the key word here is congruent. Calvin draws 2 congruent figures. We need to know what that means. There is no definition in our reference materials. Congruent means same size, same shape. It's literally copy and paste. Nothing gets changed. So, and then he does something different. So this is step 1. Let's find the congruent. Is A congruent? No. Is B congruent? Yes, if you don't worry about how they're cut, they're 2 squares. Is B congruent? No. And is D congruent? Yes. Okay, so I've got 2 sets of congruent shape, the squares and the triangles. Now, secondly, what he does is he shades an equal area of each figure. Okay, so what is C shaded? Well, it's 1 out of 4 equal parts. And then this is also 1 out of 4 equal parts. Now, 1 happens to be across the diagonals, 1 happens to be just vertically and horizontally, but they're both 1/4, even though they're a different shape, because it's the exact same square cut into 4 equal parts. So this is the hard part for students, to see that those two are equal, even though they're cut differently. right? We can do the same thing with this. If we had two equal squares, let's pretend these two are equal, right? We could also do 1/4 like this. If we did it like this is also the same as these two, and we could also do 1/4. Once again, pretend these are equal squares like this. It's all 1/4 if the square is equal. What do we have for D? Well, I've got 3 out of 4 pieces shaded, and then I've got 1 out of 4 pieces shaded. So those do not equal each other. Can't use that one. So our answer here is C. Let's see how we did here. On A, we had 35% of our students choose it. B, 10%. For the correct answer, C, we only had 42% of our students choose it. And then D, we had 13%. So, what was it about A that almost as many people chose A as they did the correct answer of C? Well, it's because they probably didn't know what this word meant. Because if you just ignore that, if the only clue you have is he shades an equal area, well, I know these two shapes aren't the same size, but at least those each look the same. It's the same orientation. It's the same type of 1/4. You're not getting cute with rotating them or anything. These are both 1/4. And so students not understanding this word congruent, they're just going to pick A. So that's what kind of made that tricky for our students. Looking for number 17, we are estimating addition problems. This is standard 3.4b. And we've got this little story problem here. Eliza riding her bike. She wrote this, she wrote this, she wrote this. She's going to round each number to the nearest 10. Okay, so they tell us what to round to, and then we want to estimate. All right, so we need to be able to round each of these to 10. Well, so what I want to do here is I want to, in third grade, we spent a lot of time talking about how close numbers are to the nearest benchmark. Okay, so I'm going to draw a little number line here. And numbers, right, 10 is kind of the middle. So I'm going to put a number line from 0 to 20. And then what I need here, right, we need our midway points. So midway between 0 and 10 is 5. Midway between 10 and 20 is 15. This is how we want students to think about rounding before we just get into the algorithm of looking to the number on the right, all of that business. Because that's kind of difficult here when these are single-digit numbers, right? So let's look at 12. Okay, if I were to put 12 here, 12 is going to be maybe right around here. So which benchmark numbers, 0, 10, and 20, is it closest to? Well, visibly, we can see it's closest to 10. Okay, so 12 rounds to 10. And then we look at 9. Where does 9 land? Well, 9 is almost at 10, so it rounds up. And this is why if we just teach our kids the algorithm, right? If you underline the spot, looks next door, well, there's no digit in the 10 spot. So if they follow the algorithm, they'd have to underline blankness, look at that, and then realize, oh, we're going to add one more because it's 5 or up, and that goes to 10. That's just a random algorithm. If they view it on a number line, they can see that 9 and 12 both are a lot closer to 10 than they are 0 or 20. Same thing with 7. 7 is right around here, and if it's between 0 and 10, it also rounds to 10, right? So each of these round to 10, so 10, 20, 30. Our answer here is going to be B. Now let's see how I did across the state of Texas. And we've got 11% of our students choosing A. Probably just rounded one number, but they didn't really add anything. B is our correct answer. 61%. Not bad. We're above 60. So we're feeling pretty good about that. Then we had 9% here. And then for some reason on D, we had 19%. So we had the most people choosing this one. And on this, right, what we might have done is we might have just added them without rounding, right? We might have done 12, 10, and 9. And that's going to be 28. And then for some reason, we ended up rounding down to 20. Don't know why we would do that, but there's a way to get to 20 as a distractor. But our correct answer here is B. So for number 18, we are looking at perimeter. And perimeter is 3.7b. But there's no picture. This is one in which we must draw a picture. A rectangular flag has a perimeter of 40 inches. All right, so I'm just going to draw something here, and this is going to represent my flag. If you see something that says a rectangular something, draw a picture, has a perimeter. Okay, so perimeter. If I look on my reference materials, am I going to find anything about perimeter? Not yet. We're not messing with formulas quite yet. That comes next year in 4th grade. So, how do we think about this? Well, we need to know what perimeter means. Perimeter means around. And sometimes we can easily think about that because we see that word rim in the middle, like a basketball rim has just metal around the outside, it's blank on the inside. If I'm dealing with the inside, that's area. This is something that 3rd graders tend to confuse. Perimeters on the outside, areas on the inside. So the whole thing is 40. Okay? So I'm just going to draw a visual like this. This whole thing is 40 inches. Has a width of 5 inches. Okay? So let's call this 5 inches. Now, what's the length? I'm going to put a box here for my missing length. So already, I need to be able to draw a picture, and I need to know what several words are in order to solve this correctly. I need to know what perimeter means, and I need to at least have an idea of width and length. So those are 3 vocabulary words our students need to get very comfortable with. Well, if I know that the width is 5, then I can say over here, this length is 5. And if I know my top is my missing number, that's my length, then I know my bottom is also my missing number. So look at what happens if I put this in a number sentence. 5 inches plus blank plus 5 inches plus blank equals 40 inches. All right, so I can combine these two, and I can say, well, 5 and 5 make 10. So I've got 10 inches plus blank equals 40 inches. Now, how much does this need to be? Right, this right here, 10 plus what makes 40? Okay, so this needs to be 30 inches because 10 inches plus 30 inches make 40 inches. And I need to split this 30 into 2 equal boxes. See how difficult this is? Obviously, this is getting into algebra and algebraic thinking, and this is 3rd grade. But we can do it without necessarily assigning variables or solving for the x. We need to think 10 is how far away from 40? It's 30, and that 30 needs to be split evenly between these 2 boxes. And so what's half of 30? Right, so that's going to be 15 and 15. So if each of these are 15 inches, let's double check our work. Let's put 15 inches in each of these boxes, see if that works. So 5 and 15 is 20. 5 and 15 is 20. 20 and 20 is 40. All right, so that's how we would solve that. So each box is the length. The length is 15 inches. This was a hard question. Let's see how we did. Well, the correct answer here is A. Only 27% of our students were able to get this. So just a hair above guessing. We had 22% of our students choose B, right? And so what that means is you took your 2 numbers, you took your 40, and you didn't know what to do, so you divided it by 5, and guess what you got? You got B. Now, C is 16%, right? So you ended up figuring out this 30. So you got this far, but you didn't divide it by 2 and cut it into each one. So you at least drew a picture and knew what was going on. But look at this. The most chosen answer was D. 37%. Once again, you didn't know what to do, so instead of dividing by 5, you subtracted 5. because you remember that you got to subtract somewhere and you end up getting that 35. So this is a very difficult problem that's really not a trick for students to remember, except for getting lots of practice drawing pictures. Whenever they get something like this and there is no visual, they need to add their own visual. For number 19, we are summarizing data. This is standard 3.8a. And we've got a restaurant here that is selling 4 sizes of pizza, small, medium, large, extra large. We've got a table that we simply need to match to the pictograph. Now, here's what we need to keep in mind. Each of these pizza symbols represents 4 pizzas. So let me go ahead and copy my table down here. So small is going to be 4, and medium is going to be 10, large 18, then extra large is 8. All right, then I simply need to match the table with one of these pictographs. So knowing that each of these pizzas represents 4 pizzas, right? So let's just draw some symbols of our own and then we'll match, right? So we've got 4 pizzas, so that's easy. So I'm looking for a small that's got simply one circle because that's going to represent 4. I'll put a 4 right there. And so each of these look good so far. Now, medium. I'm going to count by 4s, right? So I've got 4, 8. If I did one more, it would be 12. That's too many, so now I need to do the half. So that half is going to be 2. So I need 2.5. So this one doesn't work because that's got 3. That's 12. This works. That's got 12. C doesn't work. That's got 8. And then D works. That's got 10. So that 10 is what we're looking for there. All right, so far B and D are okay. 18, all right, so let's say I've got 4, 8, 12, 16. One more would be 20, so once again I need another half. So I'm looking for 4.5 pizzas. 4, 8, 12, 16, 20. So this one doesn't work. A doesn't work. I've got 4, I've got 8. So B is out. So really the only one that's left is going to be D, right? This is 16. So 4, 8, 12, 16, 18. All right, so we're looking so good so far on D. And then that last XL is going to be pretty easy. That's 8, and this has got 8. So our answer here is D. Now let's see how we did. Students across the state of Texas. So we had 12% choose A. B, we had 7%. C, we also had 7%. And the correct answer, we had D, 74%. This was tied for the first easiest. So good job, students. Really did a good job, even with kind of a tricky key right here. We were able to kind of figure this out. Of course, students have been working with pictographs even starting back in kindergarten. They use real objects to represent data. So students should have a pretty good grasp on this. All right, so moving on to the next one. Number 20, multi-step multiplication and division problems. This is 3.4K. And sometimes this is one step, sometimes this is multi-step. In this case, we are going to have just a one step. We've got 75 shirts on shelves, and he put 15 shirts on each shelf. How many shelves does Steve put shirts on? Well, let's represent this with a strip diagram, okay? So this is our total. He has 75 shirts on shelves. So on our strip diagram, I'm going to put 75 at the top. Now, he put 15 shirts on each shelves. How many shelves? I don't know how many sets of 15 he has. So I am going to simply draw it like this. I'm going to put 15, box. Now I'm going to put a question mark. and it goes the length. So that's going to represent, that's just one way to represent how many 15s does it take to get up to 75. So this is actually long division. We don't learn long division until 4th grade, right? You can do this by 15 divided by 75. This is 2-digit long division, 2-digit divisor. So now we're talking 5th grade. So there's got to be a 3rd grade way to do this, and there is. If we think of this as just repeated addition, how many 15s does it take? I'm going to make a table to keep up with it, right? So I'm going to say shelves and then shirts. And I'm just going to count by 15s. So one shelf has 15 shirts. 2 shelves has another 15, so that's 30. 3 shelves has another 15, that's 45. 4 shelves has another 15, that's 60. And 5 shelves has another 15, 75. 5 shelves. If I want to double check my work, I can say there are 5 sets of 15. Does that make 75? And if we use the standard algorithm, it does. So that is my answer, C, 5. We can use repeated addition to solve that using a table. Now, how do we do across the state of Texas? Well, we had 27% of our students choose A. So this is just, in case you can't see it, this is just 75 plus 15, right? We had 18% of our students choose B. This is 75 minus 15. So students were just trying each of the operations, addition, subtraction. The correct answer was C. We only had 46% of our students choose that, less than half. And then 9% of our students chose 6. This was some weird, you do 75 divided by 15, and then you add 1, and it's just random. Not really sure what that was. So this is all about visualizing this. If students were able to create a strip diagram and represent this and know the relationship was division, then there were ways that they could have solved this even without knowing how to do long division with a 2-digit divisor. I think the difficult thing here is picturing the actual problem and putting it into a strip diagram so they knew that they had to figure out how many sets of 15 does it take to get to 75. If they could have gotten that point, they could have just used repeated addition. So next, number 21, we are looking at the area of a rectangle. So that is 3.6c. And you'll notice this one is going to be just the equation, just the input. So we don't have A, B, C, or D to choose from. So Lena draws a rectangle on a grid, and each square has an area of 1 square centimeter, and there are 32 rows in the rectangle. Now, if we wanted to, we can actually use the grid paper here. Probably going to need to switch this to small if we wanted to do that. And we could count 32 rows. That seems like an awful lot. So let's not count 32 rows. Let's just use this as an example, right? So I'm just going to use this as an example. And I'm going to say this is 32 rows, okay? And I'm going to say there are 8 squares in each. Okay, so hopefully when we're thinking like this, we think, all right, so I can use, this is an area model right here, right? And so I can use multiplication. I can say, well, let's see, that's going to be 10, 10, 10, and it's not proportional, but that would be 2, right? And that's going to be 80, 80, 80, and 16. Add that up, right? You're going to get your 256. Or you could just multiply 32 times 8, 16, 24, 25. So either way, you're going to get 256. So we need to find this area. But that's the difficult part, right? Is realizing that it's 32 times 8 and then somehow calculating that. So let's put in our 256. 256. All right. Now, how did we do across the state of Texas? This is only a 1-point problem, and we only had 31% of our students able to get this right. So even if you were able to calculate the 32 times 8 and correctly get that to 256, you first had to realize that multiplication was the operation needed to be used. And so that is going to be difficult for some students to recognize this, even though it did say area. You would hope that would be a keyword for our students. This was the 5th hardest item on the test. Very simple setup. It's a 2-by-1 multiplication, which is what they learned for the first time in 3rd grade. But they didn't have the A, B, C, or D to choose from. And that always, for some reason, just makes it harder for the students because have they don't have the ability to just guess. For number 22, we are solving addition and subtraction problems. This is 3.4a. And we've got a simple story problem right here. At a weekend bake sale, 295 cookies were sold on Saturday. All right, so I'm just going to draw 295 cookies on Saturday. On Sunday, 88 more cookies were sold than were sold on Saturday. Interesting. Okay. So if Sundays was 88 more, this is what I need to do. I need to draw something that looks like this. I'm going to say this is Sunday. And watch this. I'm going to do a little dotted line here. I'm going to say 88 more. All right, so that's a picture that represents what happens. 295 on Saturday. Sunday is 88 more than Saturday. So I had to start with the 295 and add the 88. Okay? And then, what was the total number of cookies sold on Saturday and Sunday? So look what I've got to add. I've got to add all of this. I don't know what this missing one is. This is 295. So if I wanted to, I could add up the 295 and the 88 to see how much was sold on Sunday, but I don't really even need to know how much was sold on Sunday. I just need to add up these three quantities. So Saturday's 295, and then Sunday is 295 and the 88. And if I can get that, then I'll be good. So let's add these three. 5, 10, 18. And this is going to be 10 and then 17, 27. So I've got this 6, 78. All right, so my answer here is D. Let's see how we did. So we had 17% of our students choose A, and this is just 295 minus 88. Not sure where they got subtraction on there, but they just took the two numbers, chose a random operation. 57% chose B. B is correct. This is what Sunday is. This is the 295 plus 88, which we didn't even need to find, 383, but they didn't read the problem. They thought the problem was asking for how many cookies were sold on Sunday. The problem instead asked for how many cookies were sold on Saturday and Sunday. So they didn't read the question. C, we had 5%, so that's really low. And that was, you added 295 and then 295 and then subtracted 88. So I'm not sure why you would get that. And then the correct answer, 21%. So this was the hardest, the first hardest or the most difficult problem on the entire test. Only 21%. This is not a difficult addition problem for third graders. The problem is representing this. taking the story one sentence at a time and drawing a picture to understand the relationship between the quantities. Because that's what problem solving is all about, understanding the relationships between the quantities. Number 23, we are looking at representing equivalent fractions. This is 3.3f. And we have f on the number line. It's a multi-select, so this is a 2-point problem, 1 point for each correct answer. So which fraction can be represented by point f? Well, first, we're going to count the spaces. Right, I've got 3 spaces, so this is 0/3, 1/3, 2/3, and 3/3, which is the same as a whole. So when you're counting the number of parts, that's going to give you your denominator. So your parts are your denominator. We call these little lines tick marks. Those are going to be your numerator, right? So we've got 1/3, that's easy. It's the other one that's going to be tricky. All right, so what is an equivalent fraction of 1/3? Well, one way to make equivalent fractions is, this may or may not give us the correct answer, but you can always make an equivalent fraction by breaking each part in half. And so I'm going to do that with, let's do that with blue. All right, so I'm going to say each part in half like this. Now I need to make my new fractions. So how many parts do I got? 1, 2, 3, 4, 5, 6. So 0/6, 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6, 1 whole. So you notice now I've got something right in the middle of my line, my 3/6, which is equal to 1/2. And then this is what I'm looking for right there. 1/3 equals 2/6. And you can see this, right? You just double the numerator, double the denominator, and we just cut each part in half. So that's going to be my other fraction, which is going to be that 2/6. So that's my correct answer there. Option 3 and option 4. Now, we don't know which choices the students chose. We don't get data on that. We just know how many got 2 points, how many got 1 point, and how many got 0 points. So only 33% of our students were able to get both of these correct. That's not much. 50% were able to get one correct, which is most likely going to be that one. The 33% probably got, obviously they got both, but I bet you that 50%, a big chunk of them were probably able to just get that 1/3. And then we had 17%, 17% still unable to even identify that 1/3. We need a lot more practice on this. So this was 14th easiest. When we calculate this, right, we take all of our 33, we take half of the 1 point, that's 25. So we're looking at about 58% correct. So that's above 50%. It's about the 14th easiest. For number 24, we are looking at credit. This is 3.9D. This is a personal financial literacy problem. So it's a lot about recognizing vocabulary, not much calculating. Which statement is an example of using credit? So we don't know what that word means. Let's just look at these examples. Saves $100 per paycheck. Okay, so when you save $100 paycheck, you are earning money. I'm going to put a plus right there. When you budget $85 groceries each week, you're not really doing anything with money. You're just planning. So I'm going to put planning. When you're borrowing $400, okay, I'm going to put a minus on this one. Simply because you're getting money, but when you borrow it, that means you have to pay back. So now you owe someone else $400. And then Nina earns $250, earns $250 in tip, okay? So when you save and when you earn, you're adding money. When you're borrowing, you are adding money temporarily, but you have to pay it back. You're not really doing anything with money with when you're budgeting, right? This is just planning, so you're not using it. So even if you're not really sure what it is, if you use this strategy, you might be able to kind of eliminate, well, these two both have the same thing. We're not really doing anything with money here. So credit is when you borrow money and you have to pay it back. So a credit card is one example. You taking a loan is another example. So our answer here is C. And how did we do on this? Well, we had students kind of all over the place. 22% choose A, 29% choose B. The correct answer was C, only 30%, and then 19% chose D. This was the fourth most difficult. And so this is all about exposure. That one single lesson that we do in March before the STAAR test is not going to be enough. Students need a few opportunities to practice this because this is a lot of vocabulary so they can answer this correctly. For number 25, we are looking at comparing fractions. This is 3.3h, and we've got Serena and Ricky. They each have a milkshake, and we see that Serena drinks 5/6 of her milkshake. Ricky drinks 5/8 of his milkshake, and we need to compare the two. Well, I can draw a representation, but we don't actually need a representation, all right? So let's just draw a rectangle here. All right, so this is going to be Serena. Let's draw another rectangle. I need to try to make them as close to the same size as possible. So that's going to be Ricky. And I need to take Serena's and put it into 6. So what I'm going to do is I'm going to cut this into thirds. I'm going to cut each third into half. I'm just going to shade in 5/6. So we'll see that that's one piece short of being the entire thing. So here's your 5/6. Here's Ricky with 5/8. So what I'm going to do is I'm going to just cut this in half, cut each half in half. So I've got fourths, and then cut each fourth in half, and I've got eighths. And then we need to be able to compare these two. As you can see, Serena drinks more because look at the difference between Ricky and Serena. Now, here's the thing. We don't actually need any picture to compare these two because we have the same numerator. So if we have the same numerator, all we need are the different denominators to tell which one is going to be bigger and larger. If I have sixths, like I do for Serena, each of these pieces are larger because there's only 6 of them. The exact same whole for Ricky is split into 8 pieces. So these are going to be smaller because if I have to cut the same whole into 2 more pieces, 8 rather than 6, by definition, each piece then has to be a little bit smaller. Imagine if I were to do 5/100ths, if I were to take this particular rectangle and break it up into 100 pieces, how tiny those would be. So as the denominator gets bigger and bigger and bigger, the pieces get smaller and smaller and smaller. So we can say that Serena drinks, let's look at our options, more of a milkshake, less of a milkshake, the same amount. We can say Serena drinks more, right, because you see more shaded in, than Ricky because, and let's see why. They both drink 5 parts? No. 6 are smaller than eighths or 6 are larger than eighths. So let's make sure this matches. Serena drinks more? Yes, because sixths are larger than eighths. So this is what we would need for 2 points. Now, let's see how we did across the state of Texas. And remember, this is a 2-point problem, so we don't necessarily have data on how many students chose each of the different answer choices, but we do know that 46% of our students got 2 points, and then 21% of our students got 1 point, which means they got one or the other, and 32% got nothing correct. So if we put the 46 and then half of this one, which is going to be 11, right, we're looking at about 57% getting this correct, which makes this right in the middle. 15th easiest out of a 30-item test. That means we're right in the middle. And honestly, we could have done this without a visual, but a visual definitely helps. So that's going to be something that we can probably recommend to our students if they can draw using the same size rectangles, they can use their representations of 6 and 8s to help them answer this question. For number 26, we are representing multiplication and division. So this is standard 3.5b. And Eva has a flower shop, and we've got this little scenario here, and we need to find an equation. Okay, so let's draw a picture. Eva's flower shop has 72 flowers, places an equal number into 8 vases, sells 3 vases from the flower shop. Okay, so I want to draw a representation. If I wanted to, I could literally draw 72 little circles to represent flowers. That's going to take forever. I do recognize that this is my total. When it says she has 72 flowers, that's my total. So I'm going to make a strip diagram because I know I'm going to put my total right up there. You can put your total below, doesn't really matter, but the total spans the entire strip diagram. Now, places an equal number, so equal groups. When you see equal groups, the same number in equal amounts, the same number in each amount, any of those variations means you're going to multiply or divide. Places an equal number in 8 vases, so this is what I'm going to do. I'm going to represent this. That's going to be halves, fourths, and I'm going to cut each one of these in half, and I know I've got eighths. All right, so I've got 8 vases there. So this is basically what I'm doing is I'm taking my 72, and I'm dividing it by 8, right? I don't need to know the answer, but 72 divided by 8, that's a basic fact. So what she did is she's got 9 in each vase. Okay, so I've done this particular clue. I've done this particular clue. Now, she sells 3 vases. And then we need to find an equation to help us find out how many flowers Eva sells. Well, I can still use this same strip diagram. If she's selling 3 vases, then I just need to circle 3 of these groups. Okay? So what I need to do is I need to do 72 divided by 8. That equals 9. And then I need 3 of them, so I can multiply that by 3. That should give me 27, 9, 18, 27. And we notice we've done that right here on C. And what we can actually do is we can just combine all of that. We can say take your 72, divide it into 8 equal groups, and then multiply that by 3. So we can kind of take out this middle step, and we'll get the equation that we need. So our answer here is going to be C. Now let's see how we did across the state of Texas. So this was difficult for students. We had 27% choose A. We had 22% choose B. We only had 37% choose the correct answer, and we had 14% choose D. When you've got at least 2 of your answers near 25%, right, that means we're having a lot of guessing. Of the students that got this 37% correct, I don't even know how many of them knew the answer or they just guessed correctly. So this is one in which it's going to be very difficult, right? Um, some students on A, they just divided everything. Some students on B just subtracted everything. And D didn't even really know what was going on. This is all about drawing a representation. Even if they don't necessarily get this, if you can take your 72 and then place an equal number of flowers in the vases, well, that means we're dividing, so we can at least get rid of B. And then we're stuck with divide by 3, multiply by 3, or add by 3. If we could turn this into a strip diagram, then I think it would be a lot easier for students to say what happens if you sell 3 vases, right? Plus 3 wouldn't make much sense, but this is all about that representation. This is the 8th hardest tied on the test. This is not about solving operations. This is about representing operations, which means we need students to be flexible with different representations, including strip diagrams. So for number 27, we are looking at 2D and 3D shapes. This is 3.6a. And it is an inline choice. So we need to take a look at our figures here, and let's just name them, and then we'll have to look at our drop downs to see what our choices are. So I'm just going to do this right here so I can see what my two choices are. All right, so these are both prisms. Actually, all four of these are prisms. Okay, the prisms are three-dimensional shapes in which there's two bases that are the same shape and they get stretched out. And so what we do is we name each of these prisms by their base. Okay, so this base right here, 6 sides, this is a hexagonal prism, like a hexagon, hexagonal. This right here, you see the base, kind of hard to tell what the base is because they're all the same shape. This is a rectangular prism, and then these are also prisms, both of them, and they're the exact same prism, right? Different types of triangles, but they're both triangular prisms. All right, so they're all prisms. Let's see, the figures in group A have more than 5 faces, triangular bases, rectangular bases, but the figures in group B do not. Okay, so the figures in group A might have more than 5 faces. I'll have to check. They do not have triangular bases, and it's got to be more than 5 faces because they both don't have rectangular bases. The rectangular prism has a rectangular base, but the hexagonal prism has a hexagonal base. So I think it's going to be this more than 5 faces. So let's count and check here. So I'm just going to count the faces, right? So when I'm looking at the hexagonal prism here, right, I can count a face for each of the sides. So each of these rectangles connecting 1, 2, 3, 4, 5, 6, and then the top and the bottom 7, 8. So this has got 8 faces, and then a rectangular prism is like a cube, right? Just kind of stretched out. We know a cube has 6 faces, but I'll go ahead and count them: the back, the front, the top, the bottom, the back, right, and the side. So that's going to be 6. So yeah, okay, so that works. The figures in group A have more than 5 faces. They're 6 and 8. The figures in group B have more than 5 faces, triangular bases. There we go. They have triangular bases. I know they don't have rectangular bases. Let's count their faces to make sure they don't have more than 5. They're both the same type, right? So there's the 2 triangular bases, and then there's the 3 rectangles joining them. 3, and then the front, and then the back 5. So triangular prisms actually only have 5 faces each, so you can't say more than 5. So this is going to be the correct answer here. All right, we've got our more than 5 faces and our triangular bases. Now let's see how we did across the state of Texas. This is a 2-point problem, so once again, no data on which answer choices they got, correct or incorrect. We only had 39% of our students get both items correct. 47% get one item correct, and then 14 got neither of them. So this is one in which we would take the 39, half of 47 is going to round up to 24, right? And that's going to be 63%. So not bad. This is going to be the 5th easiest, tied for the most part. And even, it's just because we had such a large 1 point. I really do think counting the faces and then looking at the bases, the shape of the bases, might have kind of had some students struggling just a little bit. All right, so let's look at our next one here. For number 28, we are looking at 2 by 1 multiplication. And this is standard 3.4G. And it's pretty simple here. We got 8 boxes of pencils, right? I'm going to draw 8 boxes of pencils. I could draw a strip diagram if I want to. Each box, right? So each box, that means we're dealing with equal groups. And when we're dealing with equal groups, we should be thinking multiplication. So this is literally what we're doing. It's not difficult to figure out what we're doing. It's just a matter of do we remember how to multiply. So I'll do two different types of multiplication, right? So there's the standard algorithm, and then we could do partial products. Both are different strategies that students learn. Both work, right? So 8 times 8 is going to be 64. So we put the 4 down here, we carry the 6. If we do the partial products, right, 8 times 8 is going to be 64. We put them both right there. Now, for the second uh, number, we do 8 times 4 is 32. And then add that 6 is going to be 38. And if we look at this, we think 8 times 4 is 32, but that's not really a 4, that's a 40. So that's going to be 320, right? 32 with an extra 0. And you see, the only difference is we just need to do a row of addition. It gets the same answer, 384. So our answer here is B. Pretty straightforward item. And let's see how we did. 376 is only 11%, so not a lot of students. These students, for some reason, multiply correctly and then subtracted 8 to get the 376. Not sure why you would subtract that 8. The correct answer, we had 61%, so not 70, but at least it's over 60. We're feeling okay. And then we didn't get much for C or D, 14%, 13%. So there really wasn't one distractor that was tripping the kids up. Both C and D you can get if you incorrectly regroup. So these students probably need some additional support using the standard algorithm. So this was not that difficult. It was tied again for the 7th easiest item on the test. All right. Looking at number 29, this is weight and capacity. This is 3.7D, and it's just a simple recognition problem. There's not much math going on here. We've got a bottle of juice, and we just need to figure out which of these measurements are going to be used for juice. And obviously, if we look at our reference material, right, there are going to be some conversions, but here's one thing that I think might be helpful. If we're not sure, look at this word volume. We see we've got a middle section, volume and capacity. So let's see what's there for volume and capacity, because if we can at least match up that word, our students could use the measurement chart, right? So volume, and let's see, pounds. Pounds are down here under weight and mass, so let's cross that off. Feet are up here under length. Centimeters are also, they're on the far side, but they're also up here for length. So look at liters. Liters are on the other side of volume and capacity. All we had to do is match up this word, volume, and look, that's the only one that's within the volume. Pounds, feet, and centimeters are literally listed in other sections. So that is our answer D. And so this one was not that difficult. We had 14% of our students choose A, 8% choose B, 16% choose C, and then we had over 61% choose D. Just like the previous one, it's tied for the 7th easiest. Definitely recommend anytime we get something like this, if they can find a keyword, open up that reference materials list and see if they can match that keyword. That's a good strategy for students to be able to use. All right, our final item is number 30. This is composing and decomposing numbers. We're going to end with a drag and drop, and this is standard 3.2A, 2-point problem. And so we need to create an expression that is equivalent to 40,280. Now, let's look at our place value chart. So I see 5 places. So I'm going to make a chart with 5 places. I'm going to put my numbers there, 4, 0, 2, 8, 0. And then I need to remember my place value locations. Ones, tens, hundreds. So it always follows that pattern. Ones, tens, hundreds. And then I've got the ones and the tens, but these are my thousands. Okay, so that's my thousands period. This is my ones period. We don't really say this family name, but we can call these 1000s. And normally we just call them thousands. We can call these 10,000s. The next one, if we needed it, would be 100,000s, and then it repeats ones, tens, hundreds, millions. Ones, tens, hundreds, billions. Ones, tens, hundreds, trillions. That's the pattern our students need to remember. So this 4 is in the 10,000s. Okay? And then we've got our 2 is in the hundreds. So we need to grab that. And then finally, our 8 is in the tens place. And there we go. That's going to get us our 2 points. Now let's see how we did across the state of Texas. We've got, you need all 3 items to get 2 points. Okay, so you need all 3 correct. And we actually had 70%. So for the most part, we've got this. We should be feeling really good about this. 8% got at least 2 correct. You need 2 correct to get 1 point. Now, there is 22% of our students that got 1 or 0 correct, so they are really kind of clueless on this. But if you put that together, we're looking at 74% in regards to how much we did. This is the tied for the first easiest. So, good job for us. That is the 2024 third grade STAAR test.